Good morning, Professor. My name is Mansa. So we are a team member of three people, that is Shrikant, Nagajyoti, and myself. So today I'll be starting the presentation. My topic is computer, machinery, and intelligence. So I'll be starting with a basic definition, that is, can machines think? So in this, we can commence with the definition that with the two terms, that is, what is a machine and how can it think? Here we have an interrogator, here where the person remains in a different room and the other two people are in a different room. So the major aim of the interrogator was to find out who is the male and who is the female. So there are basically three people engaged in this game. The teleprompter that interacts between the two rooms is an appropriate setup that they have put in. So additionally, there's also an intermediary might deliver both the inquiries as well as a solution. So the third player objective in this game is to enable the interrogator. Giving the genuine responses might be the right approach for her. Some of the questions mentioned, like what would happen when a machine takes over the role of A in this game, that it might be a female or a male, so taken on the role of the original inquirer. So the major inquirers, can robots think? So the fact that the interrogator is unable to see, contact, or listen to any of their voices is reflected in the way that the task is framed. So it's feasible that the game may be condemned on the basis that the possibilities are titled too severely against the device. The question, isn't it possible for the machines to think something that could be defined, but it's vastly different from what a man does. So this is a major criticism, but at least we can, it is least indicated that if a computer can be built to play the imitation game effectively, it won't be bothered. So later on, we also have a what is a criticism in this game. So criticism in this is a major challenge that was explained, like in terms of the game that was being explained. That is three members that are engaged into this game and how the interrogator will find who is the male and who is the female. So later on in this game, we also have machines play a major role. So it is stated that the identification of the machines which the digital computers was respect to the thinking will be unacceptable only if the digital computers fail to perform well in this game. The significant question of not performing the experiment right away arises. They're not asking whether all the digital computers would do well in the game, nor whether the computers currently accessible will do well, but whether they're possible machines that might do well. It is only logical that we want to enable any engineering technique to be employed in our products. One, for example, would be insist that the engineering company be of one gender, but this would be unsatisfactory because it is likely conceivable to rear a full person from a single cell of a man's tissue. To achieve so would be a significant accomplishment of a biological engineering, but wouldn't think of it as a building or thinking machine. As a consequence of this, they have decided to stop the complete restrictions that any technique would be allowed. The variety of interrogators might be used, and the statistics could also be produced to indicate how regularly the current recognition would be delivered. The next would be the digital computers. Digital computers, in this paper, they have employed a human computer, where it has both conducted both the book of the instructions, where the store is one of the thing that has been referred to. The executive unit of a computer is a part of a machine that accomplishes all of the computations. These processes would differ from one machine to the other. In most of the stores, data is divided into little packets. A packet is nothing but which has a 10 numeric numbers in one machine. For example, in a methodological fashion, assign values to the portion of the store where the various packets of the data are stored. It will be highlighted with a command that occupies 10 digits and makes a unique packet of a data. It is quite convenient for them. Usually, the control with following the commands is a sequence in which they are recorded. However, an instruction like now obey the instruction is stored in a position of one, like for example, for 1, 2, 3, 4, and continued from there would be ignored. The digital computers discussed are known as discrete state machines. These are the systems that switch from one phase to another and jumps in vice versa. These states are distinguishable that any opportunity for a conflict between them can be overlooked. So there are no such machines, technically speaking. So everything is in a constant motion. So next would be contrary views of the main question. So here we basically have 9 points that have been discussed in the paper. I would be giving a brief review about each topic. So what is a theoretical objection? So it is said that to unimpressed by theological reasons that may be made to justify them. Some arguments have previously been judged to inadequate. Such an argument appears to be pointless in light of a current understanding. So when that information was unavailable, it has got a different impression. So next is a head in the sand objection. There are a variety of mathematical logical outcomes that have been utilized to demonstrate this discrete systems that has been explained in the digital computers with more of the restrictions. The short answer for this objective is that while it is almost certain that specific machines have restrictions, it has also been said that without any type of evidence, the human intelligence has no such limitations. Coming to the next one, that is a mathematical objection. It is preferable to think that man is better than the rest of the formation in some or the other regard. It is likely to be somewhat prominent in intellectuals who place a higher value on the ability to reason than others, and more likely to base their conventions man's superiority. Coming to argument from consciousness, it wasn't until a system composes a symphony as a result of thoughts, emotions that has been felt, not as a result of the random form of the symbols could be accepted that the robot equivalent with the brain that is not only produced it but it also known to be written in that way. Saying that no machine could be pleased with its accomplishments, it's sad when its verbs have been failed, warmed by the flattery, and made wretched by its errors, or furious or detection when it couldn't obtain what it wanted. Coming to argument from various disabilities, it has been argued in the paper that these are necessary qualities of the machine in generally by saying, I give you that it can make devices accomplish that all tasks you've stated, but you'll never be able to make one by any particular task. Many of these stated constraints are due to the fact that most pieces are relatively little storage space. It is also feasible to evoke a lot of speculated about the digital computers a few years ago when they were still being using unknown facts. Coming to the Lady Lovelace objection, the analytical engine makes no claim to be being the creator of anything. It can accomplish any task we give it as long as we know how to do the restrictions. This does not indicate that it will not be feasible to develop electronic components that would think of itself, or that it does not able to be set up a condition reflex, which might reserve as a framework of learning. It was written by Hartree in the year of 1947. The question of whether this is potentially possible or not is one that some of the recent advancements been raised in this paper. Coming to the seventh one, that is the argument from continuity in the nervous system. The nervous system isn't a precisely defined mechanism by any stretch of imagination. A slight deviation in the magnitude of a nerve impulse impinging on neuron can have a huge impact on the size of the falling outbound impulse. It may be stated that because of this, a discrete state system couldn't be expected to emulate the nervous control flow. A discrete state machine, like a continuous machine, must be unique. However, we still stick to the imitation games rules. The interrogator won't be able to take benefits of the disparity. If we consider a sonic or the other simple continuous machines, the picture becomes evident. Coming to the second last one, that is argument from informality of the behavior. It is impossible to come with a set of guidelines that we specify of what a man should do in every situation. There may, however, be some ambiguity between the rules of conduct and laws of behavior, which may muddle the situation. I mean, like in perspective of like stop if we see the red lights. So which one of the ad can and one should be beware of. So I mean, natural rules apply to a man's physics, such as if you can pinch him, he'll be like he can sense it. So the undistributed medium is no more formidable if we replace the rules of a behavior that manages life for laws of conduct by which he governs his life. So last one is the argument from extrasensory perception. The strange occurrences appear to the contradict all of our commonly held scientific beliefs. However, at last, in the case of telepathy, the statistical analysis approves. It is quite tough to rearrange one's thoughts in order to accommodate these truths. One of the first to vanish would be the belief that our body moves simply as per known as physical principles, along with few more that have yet to be found but are related. In response, many scientific ideas, despite clashing with extrasensory perception, appear to work in practice. So in fact, one actually forgets how to get along successfully. The last topic is what is learning machines. So learning machines in this topic, there are few evidences that have been explained that how they claim does not respond to the genuine mind. It is a kind of skin that might be lifted in order to explore the true mind. But then there's another skin to extract from what's left on and so on. So in the last two paragraphs that have been explained, they aren't meant to be the strong evidence. A better phrase would be used at recitations that tend to enhance its belief. The key feature of the learning machine is that its master is typically completely unaware of what's going inside, but he's capable of predicting his participants' actions to some level. So this should be especially true of the suspicious schooling of the machine resulting from a well-tried junior machine. So this is my presentation and I will be handing it to my next teammate, that is Shrikant.
Yeah. Hello, everyone. Myself, Shrikant. Yeah. My teammates are Manasa and Jyoti. Yeah. Today, I am discussing about machine learning in Python, main developments in technology and trends in data science, machine learning, and artificial intelligence. Um, I would like to talk about artificial intelligence. Artificial intelligence or AI refers to software technologies that make a robot and computer act and think like in human. Yeah, Mansa, can you?
Yeah, I can do that.
Yeah, please. Yeah, artificial intelligence is a theory and development of computer systems that can perform tasks that normally require a human intelligence, speech recognition, decision making, visual production. For example, are futures of human intelligence that artificial intelligence may possess translation between languages is another future. Can you please go to the next slide? Machine learning. Machine learning to is an idea to learn for examples and experience without being explicitly programmed. Instead of writing code, you feed data to the generic algorithm and it builds logic based on the data given. It's considered seven sections. I will talk about section one. We'll introduce a Python as a tool for scientific computing and machine learning before discussing the optimization that make it both simple and performant. Section covers how Python is began used for conventional machine learning. And section three introduce the recent developments for automatic and machine learning pipeline building and experimentation via automated machine learning, where automated machine learning is a research area that focuses on the automatic optimization of machine learning hyper hyperparameters and pipelines. And coming to the section 4, we discussed the development of GPU accelerated scientific computing and machine learning for improving the computational performance as well as the new challenges it creates, and focusing on the subfield of machine learning, that specialization in GPU accelerated training of deep neural networks. It's like DNNs. We discussed deep learning in section 5. In recent years, machine learning and deep learning technologies advances the state of the art in many fields, but one often quoted disadvantages of these technologies or more traditional approaches is a lack of interpretal and explainability. And last section, but not least, it's provide a brief overview of the recent developments in the field of advertising and advertiser learnings, which aims to make machine learning and deep learning more robust, where robustness is important to property in many security related real world applications. Like, yeah, Py- can you please next slide? Yeah, it is a Python scientific computing and machine learning in Python optimizing Python's performance for numerical computing and data processing. Yeah, Python is a popular platform used for research and development of production systems. It is a vast language with number of models package and libraries that provide multiple ways of achieving tasks. And Python and its liberally like number of pandas like skit learn and matplotlib are used in data science and data analysis. They are also extensively used for creating a scalable machine learning algorithms. And classic machine learning, deep learning is a machine learning subcategory that focus on parameterized of DNNs. Non-deep learning based machine learning will be referred to as a classification machine learning. And for the clarity, all the machines learning is a catch-all phase that encompasses both deep learning and classics is a machine learning. And deep learning is a particularly attractive for working with large unstructured data sets such as text, images, and in construct. Most classical machine learning techniques we are developed and with structured and main is data tabular form accompanies observations are sorted a column like in 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 the industry standard for classical machine learning. In the industry standard, Python library used to the future engineering and classified machine learning modeling are medium-sized databases. In small part of because in the is consisting an institute of to find a right balance between providing useful futures, explorations in machine learning and artificial intelligence. Yeah, addressing class imbalances, skewed class labor distribution present one of the most significant challenges that arise when working with the real-world database, such as the first two techniques resampled. Yeah, and coming to I will conclude this topic, my topic. Yeah. And explain related to the ability to comprehend how model works and beneath the hood in sample and simple words, whereas interpretability refers to the ability to observe the impact. The impact refers to the ability to the observe to change in input parameters and expected to outputs. Adversarial attacks can happen during the training positions attacks in the predictions phase following training. Evaluation results are divided into two categories. It's a white box and black box. In black box attack, the attacker has no knowledge of how machine learning systems works except the data types and accepts as an input. Yeah. Next topic, my team member Jyoti is take over the. Please take out the next topic.
Yes. Hello guys, my name is Jyoti and my topic is a survey of qualitative merits for benchmarking, contemporary and deep learning hardware and frameworks. In this topic, we will explain the benchmarking concepts and machine learning concepts that as GPUs and FPGAs and ASICs. We cover all these topics and also we cover the benchmark results, benchmark measures, and then the data sets. And GPU means the graphic processing unit. GPU can handle the large bunch of the data, so that's why we use GPUs in machine learnings and video editing and gaming. And the FPGA means field processing gate arrays. It is a type of circuits that allow a client or manufacturers can consume it can be manufactured. And the ASIC is application say specific integrated and circuits. It is a chip that can be device and a piece of hardware that only employs the ASICs. And the next is the introduction. Deep learning technologies are still growing after the 75 years of development. In 2018, one company, the name is an IT research and consultants company, They point out the deep learning networks triggers many industrial projects as well as the research topics. And the deep learning algorithms assumes easy influence by the image data by putting the high quality photos the into the deep learning algorithm. It can be manufactured. Accuracy of the system is also increased. They shows this. And also in Oxford Dictionary, benchmark means the to access or check by comparison with an established no. This is the definition of in the Oxford in dictionary. And image data means there are so many types of image data. That is CIFAR 10 MINST, minced and ImageNet, Pascal, visual object classes. There are so many types of all images. They are all color images. Minst has digital hardware images, and these images are black or white. And benchmark, even though the previous research papers provide knowledge of deep learning, it is hard to find a survey discussing quality benchmarking for bench learning hardware devices and deep learning software frameworks. And the next is there are 7 key characteristics of this benchmarking. They are relevance. Relevance means benchmarking should measure important features. It measures the important topics of this project and the representative. It means the performance merits should be broadly accepted by the industry and the academic. And quality means all the systems should be fairly compared. In the project, all the systems are compared in fairness. And representability, benchmark results should be variability and cost effectiveness. It costs the low. And the scalability, benchmark test should be measured from the single server to multiple servers. And transparency, benchmark merits should be readily understandable. And artificial intelligence, hardware and the deep learning framework allows to discover both strength and weaknesses of the deep learning technologies. What's the deep learning? Deep learning is in machine learning language, deep benchmarking is the practice of the compared tools to identify best performance technologies in the industry. Compare different machine learning platforms can be difficult task due to large number of facts involved in the performance of the tools. And the next is the deep learning hardware. To compare the many non-AI algorithms, AI algorithms frequently benefit from the multi-core systems and high bandwidth memory. And depending on the set of computation being analyzed, a hardware platform might have more or less computing power. That means the AI algorithms often benefit from Mericone hardware and high bandwidth memory. And the FPGAs being comparable can be configured to perform well on AI algorithms, although currently they lack the rich software layer needed to fully achieve their potential in the AI domain. ASICs are similar to FPGAs in this regard. Since the principal simply configures FPGAs is the kind of ASICs. Thus, GPUs and FPGAs and ASICs have potential to machine learning algorithms in part because of their capability of parallel computing and high-speed international memory. And the lower precision can also improve memory buffer and the memory utilization as well as the storage capability. GPU often useful to the AI algorithms compared to CPU because FPGAs are adjustable. They can be designed to perform well on AI algorithms. However, they personally lack the complex software layer required to fully realize their AI potential. And the ASICS similar to the FPGS in this point. And then my next topic is devices. There are 5 devices. These are CPU devices. CPU are specially unitarily performances. They are dedicated to accelerating real-time 3D dimensional graphics, and GPU contains an internal cache and high-speed bandwidth and quick parallel performance. The CPU caches accelerate matrix multiple routines because these routines do not need to access global memory. And the next is FPGS devices. FPGS have dynamic hardware configurations, so hardware engineers develop FPGS uses hardware description languages that calls HDL, includes VHDL or however some use cases.
Sorry for the inconvenience. Have we had an issue with the Zoom meeting link? So Jyoti would be continuing with a presentation with the topic devices.
Continue to the devices, they have GPU devices, and GPU devices means are specifically unified processors that are dedicated to accelerate real-time three-dimensional graphics. GPUs contains a internal cache, high-speed bandwidth, and quick parallel performance. In GPU, cache accelerates matrix multiplication routine because this routine do not need to access global memory. And next is the FPGA devices. FPGAs have dynamical hardware configurations. So hardware engineers develop FPGAs uses hardware description language, that means HDL. It's also included to VHDLs. And some use cases will also involve the energy sensitive sensors. FPGAs devices often better performance per watt than GPUs, according to which compared to the GPS devices often have a 3 to 4x speed of compared to FPGAs. And the next is ASIC devices. ASIC devices have high throughput and low energy consumption because ASICs are fabric chips designed for special applications include of graphic it's genetic tests. While testing AlexNest, one of the configuration nature networks, the arrays confuse. Okay, and next is the enhanced hardware performance. Even though multiple cores CPUs are mainstream technologies, and the next one is the qualitative benchmarking merits on machine learning hardwares. It's GPUs, FPGAs, ASCS can be used in different domains besides deep learning, include cloud services and the edge devices. There are 11 qualitative benchmarking merits we design on the machine learning devices. And the next topic is and deep mainstream of the deep learning and frameworks. It's 18 frameworks divided in 3 categories. There are mature frameworks and developed frameworks and the inactive frameworks based on the wide range of users, support teams, and develop interfaces. Although developing frameworks are not yet widely employed in enterprises and the research projects, some of them might be useful in the certain domains. Retired frameworks are mostly inactive, like mature frameworks, developed frameworks, and inactive frameworks. Qualitative benchmark merits for deep learning frameworks. And although the frameworks are not yet widely employed. And Next one is a machine learning benchmark organization. Machine learning performance is the machine learning benchmark organization that offers useful benchmarks that training and inference on deep learning hardware devices. Machine learning performance and its members are associated with the advanced chip hardware companies and leading research universities. Hardware companies included Google and Intel. Research universities included Stanford University, Harvard University, University of Texas at Austin. ML Performances is the machine learning benchmark group that provides the mission for the deep learning machine devices for training and inference. And ML performance involve the benchmarking merits, data sets, deep learning algorithms, and deep learning frameworks. ML performance members deep learning algorithms on hardware devices then record the executed time. And the next one, my topic conclusion is, as deep learning technology advances, it's important to know the dimensions and methodologies for accessing deep learning hardware and software. In future, benchmarks for developed learning can bridge the gap between academics and industry. In compared to many non-AI algorithms that can commonly encounter in reality, AI algorithms benefit from many core systems and high bandwidth memory. Thank you.